we'll cover the problem find minimum in rotated sorted array. So here, imagine we had a sorted array of integers like this, but it was all rotated by some amount. So you can imagine we kind of shifted all these elements to the right and numbers started to overlap. So if it goes past the end of the array, it jumps around to the beginning. For example, if we shift by 3 places, we get something like this: 30, 40, 50, and then 10, 20. And we want to find and return the index of the minimum element in this array. And we know that all the numbers are unique. At first glance, this doesn't feel like a binary search problem because the array isn't exactly sorted. But it is kind of sorted, and we can try to see if we can find some sort of decision that allows us to cut the search space in half. And if you think about this, since this array has been rotated by some amount, we must have some kind of big chunk of numbers here and then smaller numbers afterwards, right? Because the fact that it's rotated means we took big numbers from the end. Like even if we rotated by 1 position, then there must be a big number at the beginning. There's a nice visual that they have here. So if you look at this, remember we want to apply some sort of filter, kind of distill this array into 2 sections, and then we can start using our boundary logic. So if you look at this graph, kind of trying to figure out how to do that, you can see there are 2 sections. We've got our big numbers right here, and then we have our smaller numbers. And if we want a precise way to define that, then we can just look at our last number here. Everything that is greater than our last number is our big numbers set, and everything that's less than or equal to our last number is our smaller numbers set. If we use that framing, then we just want to find the left boundary, kind of the first occurrence of something that is in our set of numbers that are less than or equal to the last number. So the filter we apply is going to be less than or equal to the very last element. So here we would get false, 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 true, true. And so you can see this here. For some reason they wrote less than 20, but I think it should actually be less than or equal to 20. And it looks like that's what they're doing here. Now, when you look at the array like this, finding the minimum element just becomes a question of finding the first occurrence of a true. And we already know how to do that. So we can go ahead and code this out. So here we're going to have our left index. It's going to be 0. Our right index is going to be last index. We should create that above. So the const last index equals array.length minus 1. Now we'll come here. We'll continue so long as left index is less than or equal to right index. We'll grab our mid index with our get mid index function that we are creating so that we can kind of centralize our computation so that if it ever does need to change, it's nice and easy to do so. And this function takes in the left index, the right index, and we're going to do our math right here. So we'll grab our mid index using left index plus math dot floor right minus left divided by 2, and we'll return that value. Mid index. All right. Now here we can grab our mid value. It's going to be array at mid index. Now another thing is we're going to be comparing this guy against the last index, or the last value actually. So I'm going to grab our last value, which will be array at last index. And I realize we also need our answer. So we'll say minimum or min element index is going to be, we'll start it at -1. So we'll have a not found, or we'll say a no minimum found, which realistically should never happen because every array should be having a minimum. I guess unless we had like an empty array or something like that. But yeah, in that case, no minimum found is a valid answer if we did have an empty array. Okay, so now our filter was less than or equal to. So we can say is less than or equal to last element. And that's going to be mid val less than or equal to last val. If this is true, let's see, we want to find the first occurrence where this statement is true. Okay, so we'll say if it's true, then we can update our answer and say, hey, we have a new potential right answer. And then also we should be searching everything to the left. So we can say right index is going to be mid index minus 1. Otherwise, we will say left index equals mid index plus 1. So to be clear, if we found something that's less than or equal to the last, we know that we're in our smaller chunk of numbers. So it's possible that our current number just is our answer, which is why we're going to update our min element index. But we're also going to search everything to the left by moving our right pointer, because there might be something else that is also less than or equal to last that is smaller than the current element. Now, if the current element is greater than the last element, we know that we've not found our smaller section of numbers, and we need to continue moving to the right. So we move our left index across to the right of the mid index, and we reduce our search space in that way. In the end, we go ahead and return the minimum element index, and we can see if this will work. Now remember, what we know here is there's two cases when we're updating this. Let's see. Okay, it looks like everything passed. Okay. Remember, there are two cases when we update this. Either we found the right answer, in which case we'll never find a better answer and we won't update it. Or if we have not found the right answer, then this is going to be overwritten in the future. Okay, well that's all for this video, and thank you for watching.